Hi everyone, this is Anil Bhatia again from PAT Fun Begins, Practical Architectural Training, a unit of ADS, Architects Design Studio. Today I am going to start a new topic, how to read structure drawings, and also how to explain these drawings at the site. We have to also understand certain standard reinforcement details, shuttering methods, and other details related to concrete work at site, only concrete work. All these things sound very difficult, but are actually not. Step by step, I shall explain first how to read structural drawings, starting from the foundation level. Here, let me clear one thing. Every structural engineer has his or her own method of making these drawings. But generally, if you learn to read one type of structural drawing, then all other drawings will start looking similar. So now we shall be looking at the foundation drawings of one building. These drawings were made by our consultant, Mr. Noble Thomas. This is a project our firm ADS is doing at Kurukshetra. This particular drawing is one of the blocks out of a complex of 6 blocks. We shall not talk here about how the layout was done and also nothing about excavation and PCC. We shall assume that all that is done, and as I had explained in my previous videos, even waterproofing is done. Even a protective layer of 2-inch thick PCC over it is also done. So the stage has come now for the raft reinforcement to be tied. And now have a look at the drawing on the left. It sounds very complicated, right? But actually it's very simple. There are 3 or 4 things to notice in this drawing. First, see the changes in the raft thickness in various areas. The main raft is shown in white. This is 750 mm thick. And the next thing to note is the stitch slab, which is 200 mm thick. Let us zoom to the area marked in red. Here you can see the stitch slab, which is 200 mm thick and is marked in yellow. All around it is the 750 thick main raft. There are 7 columns in this zoomed area, and all these are linked with the beams which are shown in green. Now have a look at this section. Again, section XX. This section shows that the general thickness of the raft is 750 mm. But at certain places, the thickness is only 200 mm. Have a look. These areas are called stitch slabs. Basically, the main loads from the columns are being transferred to the 750 mm thick raft portion, and the stitch slab within the building has no columns on it. Have a look at the drawing again. Yes, the stitch slab outside the building has columns on it. We will look into that later. Let us concentrate inside the main building for the time being. Let's look closely at beam RB2. You can see in the section how RB2 is projecting out of the slab. Have a look at the section. It is projecting out of the slab. Till now, we have identified 3 elements in concrete. First, the main raft. Second, the stitch slab. And third, this beam. Now, let's look at the 4th element, which is the pedestal. This is not there in the zoomed portion, so we'll go back to the other drawing. Look closely. At one of the pedestals, it is easy to identify and understand that in areas where columns are carrying more loads, we have to have pedestals. The pedestals increase the thickness of the raft in that particular area where the load is more. Have a look again at the section also. So basically, in any raft, these four elements are generally always present: main raft, stitch slab, beams, and pedestals. Now let's move on to understand how to read these drawings for reinforcement. For this, let's look at the section again. The main raft has a reinforcement layer at the bottom. This is called the bottom reinforcement. And the main raft also has a layer of reinforcement at the top. This is called the top reinforcement. Both these are shown in the section. Okay, so now let's look at a scale model of the reinforcement of one particular zone. In this zone, this is the main raft, which is 750 thick. The yellow portion is the stitch slab, which we talked about, which is 200 thick. The green band are the beams all around, and we have 7 columns in this area. So again, this portion, white portion, is the 750 thick raft, and this white portion is also 750 thick raft. This is the RCC wall all around it. This is the RCC wall all around it. If we see this in section, this is at the same scale. This beam is seen here. This beam is seen here. This stitch slab is this one. And this is the 750 thick raft. And this is the 750 thick raft. And this blue wall here, RCC wall, and this grey RCC wall, these are here. This is the blue wall and this is the grey wall. So this is a section cut through this area. Now we have to start with the reinforcement of this area. So here we have the bottom reinforcement of this area. This is the bottom reinforcement all around the stitch slab, and this continues further. It continues in all directions. So we have made a part of it. After the bottom reinforcement is tied, now what do? We have the extra bottom reinforcement. Now this extra bottom reinforcement, you can see here, this extra bottom reinforcement is right under the columns. So right over the columns, under the columns. Okay. So this is the second reinforcement, second extra reinforcement coming here. Similarly, we have the third extra reinforcement coming here, and then we can add on all the extra reinforcement under all the columns. So this is the first step where you have the bottom reinforcement and the extra bottom reinforcement. So now we have the bottom reinforcement, main bottom reinforcement, and the extra reinforcement for only 5 columns, not all 7. In this case, there were only 5 columns which were having extra reinforcement at the bottom. After this, the next step is tying the columns. So this is one of the column. We will study in detail about the column later, but presently we are just focusing on the stages. So this is the column which is coming at this place. The second column is going to come at its place. So we tie all the columns now. That's the second stage completed. So we have all 7 columns fixed in position. The bottom reinforcement was fixed first. Then the extra bottom was fixed, which was only in 5 columns. And we have now fixed all the columns. Now we have to start fixing the beam. Now if we try to fix the beam this way or sideways, so these stirrups will not let the beam either enter sideways or enter from the top. So that means the stirrups of this beam cannot be tied and inserted inside this columns. So we have to remove the stirrups. Actually, we don't have to put the stirrups first. First we have to have the reinforcement going inside these columns. And once the reinforcement is inside, then we have to fix the stirrups simultaneously. Once you insert the reinforcement from here, you have to fix the stirrups along with it. So we'll try to do that now. Okay. We have this 4 reinforcements, 2 for the top and 2 for the bottom, and we're trying to insert these reinforcements from this side. So we have now managed to put these bars through this column. So once the bars are through this column, they should not enter this column, otherwise how will you insert the stirrups? These stirrups have to go inside first, and all the stirrups required from this column to this column must be pushed inside, and then these bars can further go through this column. Now we have put this reinforcement inside till this point, and we have moved the stirrups inside. So all the stirrups required between this column and this column have been inserted inside. Now we have to further move these reinforcements into this column and move this way, and then again insert the stirrups from here, and finally the beam ends here. So now the 2 beams are in place, and we haven't tied the other 2 beams. So we are assuming that all 4 beams will be tied. After this, what is the next stage? Now we have the beams in place, 2 beams in place. The other 2 beams will be done similarly, so we won't go into that. After this, there are 2 ways we can work after this. One is we start putting the cover blocks. These are the cover blocks which we have to put under the reinforcement. Under the reinforcement, put cover block all around. The second method is that we tie the stitch slab reinforcement. So once the stitch slab bottom reinforcement is put in place, even after that we can start with the cover blocks. After this stitch slab reinforcement, all we have to do is put the top layer of the stitch slab reinforcement in place. This is the top layer, that's the bottom layer. So we put the top layer in position for the stitch slab, and the cover blocks under the bottom layer, they are all done. So we already have these cover blocks. We can put them all around under the main bottom reinforcement. After that, all we have to do is put the top layer of the main raft reinforcement, top layer. This is the top layer. Now this will fall down if we don't give it supports. So we have these supports below made in the Z-shaped sections, and this looks something like this. Something like this. These are the supports which are put fixed below it. In local language, they are called godies. And we just have to put this top reinforcement, tie this at the top level of the under the beam. So this reinforcement actually has to go inside the beam because the beam is projecting out. We've just made it like this because it's not possible to insert it inside the beam. So this reinforcement will go inside the beam, inside all the beams, because the height of this slab is 750 and the height of the beam is more than that. So for the purpose of showing the model, we've just put this top layer over the beam. Otherwise, it will be inserted inside the beam, and that is a complete model of how raft reinforcement is tied. So the structural engineer has to show all these reinforcements in his drawings. For this, he makes a set of 3 drawings. The first drawing shown on the left shows the reinforcement for the main raft and the stitch slab, both top and bottom reinforcement, which is throughout the raft. The top reinforcement is shown as a dotted line. Have a look, we'll zoom onto that dotted line, and the bottom reinforcement is shown as a firm line. So this representation is same for main raft and for the stitch slab. Now read the firm lines and check the chart for those. Have a closer look at the chart. As shown in the plan, the firm lines are represented by the symbol D. This chart shows D to be 20 torr bars at a center to center distance of 200 mm. Have a closer look. This is written as 20 torr at 200 center to center. So basically the bottom reinforcement in both the directions in the main raft is the same, 20 torr at 200 center to center. In our local language, we say that the bottom jal, it's called jal, is made out of 20 torr bars which are at 200 center to center in both the directions. Have a closer look again. Now let's look at the stitch slab bottom reinforcement. As shown in the plan, this reinforcement is marked as A. We are going to zoom on A now. Now look at the chart again. A represents 10 torr at 200 center to center. That means in both directions, the bottom reinforcement in the stitch slab, the thinner slab, is 10 torr at 200 center to center. So we have read the firm lines till now and got the hang of what they are. Now let's read the dotted lines and check the chart for those. As shown in the plan, the dotted lines are represented by the symbol D in a particular zone. This chart shows D to be 20 torr bars again at a center to center distance of 200 mm again, written as 20 torr at 200 center to center. So basically the top reinforcement in both the directions in the main raft is 20 torr at 200 center to center, and this was similar in the bottom of the main raft also. In local language, we say that the top jal is made out of 20 torr bars at 200 center to center in both directions. Now let's look at the stitch slab top reinforcement as shown in the plan. This reinforcement is marked as A again. Now let's look at the chart again. A represents again 10 torr at 200 center to center. That means in both the directions, the top reinforcement in the stitch slab 2 is 10 torr at 200 center to center. Now we have completed this drawing. There is nothing else in this drawing. Let's move on to the next drawing. This drawing represents the extra bottom reinforcement. Now you notice this extra bottom reinforcement is required almost only below the columns. This is because the main load is transferred here by the columns and then spread to the raft. Again we refer to the chart for this. Let's look at only one column base. Let's zoom on to one column base. In this column, the extra reinforcement in both directions for bottom is shown as D, again 20 torr at 200 center to center. So apart from the original reinforcement, bottom reinforcement, which was again 20 torr at 200 center to center, we have to put this extra reinforcement also below the columns, and it happens in other places also, which is very rare. And the distance this is to be carried over all around the column is also given. Have a close look. This is extending 1000 on all sides of the column, all sides. This drawing represents only this much, nothing else. So the first drawing represented the through reinforcement, and this drawing represents the extra bottom reinforcement. Similarly, now look at the third drawing. This shows the extra top reinforcement. This presently is not required in this particularly zoomed zone, so we have to look below that zone. Look at the area below that zone. It shows that as B, and B in the chart, let's have a look at the chart, is 12 torr at 200 center to center, and the distance this has to be tied is given by this arrow. Have a closer look at the arrow. So from this point to this point where the arrow is shown, till there we have the extra top reinforcement. Now let's look at the model again. It becomes crystal clear that only 3 drawings were required to represent reinforcement for the raft. The 4th drawing was the column. So we are going to take up the column later on. So we have to understand how to read column reinforcement drawings and beam reinforcement drawings in detail in the next video. After that, we shall discuss the RCC retaining wall reinforcement in detail and how to read these drawings. I really hope you have followed this step-by-step method of how to read structural raft drawings. Again, I must mention the names of my team who has worked with me to make this presentation. Monica, Shubham, Sagarika and Shivangi helped me in most of this presentation. And my present group of interns worked really hard to make this model, which took them almost 10 days. Our next video shall complete the understanding of raft structural drawings. Please note down our email ID and we will love to answer all your queries. Till then, bye, take care.